Alright, so we've already learned about basic arithmetic, the plus, the minus, the division, and so on and so forth. But if you wanted to do more beyond just the basic arithmetic, we do have a class in java.lang package called the math class. Within the math class, you'll find several mathematical methods that are very useful. It's really endless ones, but we'll look at a few. We'll also make a point of putting this link in the description so you can have a look at your own time when you want to practice. So for example, because again all the methods in the math class are static, as you see here, they're all static methods. As we learned earlier, when you're making a call to a static method within a class, then you can just call it like this without instantiating the class. So that's why math.course is an example of what you'd expect to see in code examples that are coming up. So you can either import it like this. So the import statement follows this structuring, where you have import statement, static word, and then the package with the respective class name. There are statics to represent every other method that you're going to import. Now we will be looking at examples. For now, let's start with this, and then we'll proceed on to look at the other examples as we move along. So I will be switching to IntelliJ. I'll make a point of attaching the GitHub link also for this one. So I'll attach the link to this, and you'll find the examples I'm about to show you as they are. You'll find them within the GitHub link that I'll attach in the description. So before we go to discussing the random class and method, let's look at this example here. Given this double A, double B, and for two integers C and D as they are, if I wanted to find an absolute value for A, just make a call to the absolute method from the math class. If I wanted to find the ceil, I'll call the ceil method. If I wanted to find the floor, I'll make a call to that. If I wanted to find the closest integer, I'll work with rint. If I wanted to find the maximum, I'll work with that. If I wanted to find the minimum of the past variables, then I'll work with that. So please note, we had also looked at max and min earlier on. This is another availability on that, depending on what you want to do. So if I run this, then I expect to see the absolute value, the ceil value, the floor value, the rint, the max, and the min, as you're seeing here. You will have a chance to practice with this. There's a link in the GitHub link in the description. Another thing you can do with the math class is to work with exponential functions. So we have if you want to make a call to the constants, because the math class has two constants. Let me just go back and show you the two constants. So we do have pi and e as the two constants. If you're keen on your mathematics, you probably already remember pi, at least, if not anything else. In a previous session, the one directly before this, we looked at these converter representations, so you get more practice with them here. If you want to find the exponential of a value, you work with this. If you want to find the logarithm of a value, you work with this. If you want to find the power of one value when it's raised to the value of the other, then you work with the power. And then this one is for the square root, among other methods. So if I run this, you're just looking at common ones that you're likely to work with in your program. So if I run this, then I will be able to find these results here. Again, you can always play with that. There's a link in the description. Maybe you'll copy it and try and toggle it while you're practicing on your favorite IDE. Finally, we do have the trigonometric, at least finally up to this point, we do have the trigonometric demo. With this one, you'll get to practice with the sin, the cosine, the sin, the tan, and the conversion to degrees, because the sin and the cosine and the tan in Java, they expect you to pass in radians. So if you want to present your results as degrees, you'll need to work with the toDegrees. If you want to represent to convert your degrees to radians before you use them with the sin, cos, and tan, then you'll need to work with toRadians. So those are the methods available, and they allow for this. For example, we do have these degrees, 45 degrees. First, we convert it here to radians before we can use them within the cosine, tan, and sin functions. So have a look at this. If I run, everything should be in order. This is the same that you will see in the GitHub description. for functionalities that we have in Java. Now to random. So if you just want to generate one random number between 0.0 and less than 1.0, you can work with the random method as like this. But if you want more functionality, then you should consider working with the java.util package random class. So for example, if I'm working with this and I want values that are more than between 0.0 and 1.0, then I might need to introduce arithmetic functions like the multiplication function and do the necessary. However, if I want more functionality, then I should consider looking at java.util.Random class. So let's go have a look. This is the random example. So we do have this double here, a random double, and I expect that this, once I print this out, I should be able to see values between 0.0 and 1.0 randomly. Then we have this other one, the random int, and with this I'm working with arithmetic function of 10 to ensure I get between 0 and 9 instead of 0.0 to less than 1.0. So if I needed more functionality besides that, then I would need to instantiate the random class as I'm doing here. Since I'm only making a call to it once, I didn't see the need of working with an import statement. I just did it directly like this, or I left it as it is. So after that, then I would be able to work with this instance from the random class and the methods within the random, and to make a call to the methods within the random class and do the necessary as the method directs. For example, with nextInt, when I want to generate a value between 0 to 9, then I can set the bound of 10. Then I can use that within an iterative loop of up to three values. Then I would be able to print random numbers of up to 3 values. So let's have a look at this and see. Then I'll go and show you the random class. So here we go. Here we have the random double. That's just one value generated from this. Then so it has to be between, it can be between 0.1 and up to less than 1.0. Then with this one we have 0 generated from this. If I run this a few times, I should see a different value. Then with this other one, since I'm bounding it to 10, then it means it has to be something between 0 to 9, and at random 3 values because of this iterative loop. So I'm getting 4, 0 and 5. Let's see if I'll get a different result if I run this again. Not quite from the random int, but there is something different showing up with this other bit and this bit here. Let me run this again. I'm trying to see if I will actually eventually get here. There you go, a random value for this bit here. So have a look at this. So I'll practice with them. I think it's best if I leave it as it is, and then I'll share with you the GitHub link so you can practice it on your own to try and ask yourself questions and see if you're missing on anything, so you'd see how you can apply it. And I'll also attach this link from the random class. Let me just show you the nextInt that I've just shown you here. This one, here you go. So it is going to uniformly distribute the value of random numbers in sequence, and it expects you to put in a bound value. So even if I worked with 500, at the end of it, it will still just give me up to 10 because of how I've placed it in my give me up to 3 values because of how I've placed it in my code. Let's see an example here. Let me work with 55 and see what 55 gives me, because so far I've gotten values between 1 and 9. So 55 should then give me between 0 and 54. If I run this, I should see something different here. Yeah, here you go, 27, 52, 38. So really it depends with what you're going for. Have a look at all the other methods and see if you could use them. Maybe compare nextInt with this overloaded nextInt. And that is that on this bit. I'm trying to keep them as short and sweet as possible. I hope you'll get enough practice if you go onto my GitHub links and recreate them on your own IDEs. Have fun, and I'll see you on the next one.